Okay, so that video was discontinued due to some error in the video after that part. So we'll now move on to this part 2 of this second video. Okay, so we talked about this example over here. Now note down this example, and we will be doing this example over here, right? So firstly, when we see this question over here, we have to recognize the type of, identify the type of complex it is. So as we can see, the cation part is a complex, so it is a cationic complex. So just how a cationic complex is named, we will name it in a similar way. So we have to see the ligand first. What is the ligand over here? This part enclosed in the parenthesis. So this ligand is over here. So now we have to refer to the table, which ligand this is, what is its name. As we see at the point number 21 of the table, this is ethane 1,2-diamine or ethylene diamine. Okay, so this is NH2 CH2 CH2 NH2. The same thing is over here, NH2 CH2 CH2 NH2. The same ligand is over here. Now as we know that since this we have to name it in that order, so this 3 is over here, so you would obviously write a tri over here, right? And then you would name this ligand. But let me tell you, since this ligand, this ligand will be named in a different way. In this ligand, the name base tris will be used. Why? There is a particular reason for this. Now that's the reason why I created a separate video, because it was getting too long. Okay, so this is an important note. If di, tri or any such numerical prefixes are used already in the name of the ligand itself, they are present in the name of the ligand itself, then while talking about the number of ligands present in the coordination compound, we'll be using bis instead of bi for 2, tris instead of tri for 3 for x and y. Like over here, when we saw this example, we easily wrote tri over here, we easily wrote tri over here, because H2O and NH3 have names aqua and amine, which do not have di and tri in their name already. But when we have a look at the name of this is ethane 1,2-diamine or ethylene diamine. You can hear the word di, so that di is also already present in its name. So we won't be using a tri or a di over here. What we'll use for 3, we'll be using a tris. This tris will be over here. Then over here, you don't need to include a bracket, that was unnecessary. We'll just write tris, then ethylene 1,2-diamine, or in short form you could also write it as En in a bracket. I have written over here En, or ethane 1,2-diamine or ethylene diamine. Then the next thing that you will do, all ligands are over naming. Then after the ligands, we know that we have to name the metal over here. After all the ligands are over, we have to name the central metal atom. So we'll name the central metal atom. What is the central metal atom? Cobalt. Now we'll find out the oxidation number. Now to find out the oxidation number, we'll assume the oxidation number of this to be X. Now what is the charge on this thing? We have to refer to the table. When you will see the table, you will find that the charge on this is 0. Okay, and SO4, you know already, SO4 exists as SO4 2-, so the charge on SO4 is 2-. Now we'll find out the oxidation number of this. So number of cobalt atoms 1, oxidation number assumed X, number of this molecule 3, charge on it 0, then this whole thing into 2, right? Over here into 2 has to be done, because this whole thing is coming twice. This whole thing into 2, then plus SO4. SO4 exists as there are 3 molecules of SO4, so 3 into charge on SO4 2-. Oh shit. Yeah, so the charge on SO4 is 2-, so it will be -2 over here, and this whole thing will equate it to 0. So what will come out from here? We'll see that 2x minus 6 is equal to 0. X will turn out to be 3. You can see x into 1 plus 3 into 0. This whole thing into 2, because this whole thing was existing 2 times. There are 2 molecules of this entire thing. Then 3 this, because the number of SO4 is 3 and the charge on SO4 is 2 minus. This whole thing equated to 0 will give X as 3. X is the oxidation number. After the metal, central metal name, we'll include the oxidation number. So cobalt 3. Then what is the SO4 named as? Sulfate. So cobalt 3 sulfate. Simple. This is how the naming is done. Okay, nothing very hard or anything like that. You could also write over here tris. After that you could name it like this. In fact, it would be more mark scoring if you write it like this: ethane 1,2-diamine, ethane 1,2-diamine, and then cobalt 3 sulfate. Whatever. This En is just a short form. Okay, it is a short form for this entire thing. Okay, I hope you understand this much. You understood this much? Okay, so the next part we'll be learning will be how to name an anionic complex. Okay, since we already learned how to name a cationic complex, it won't be very hard to learn how to name an anionic complex. The technique is totally similar. Okay, so an anionic complex, as we know, can be represented in this form: EnMlXl-y, where the complex part is the anion. Okay, so how we'll name this? So the first thing, these all prefixes, let there be m over here, anything over here, this prefix and this prefix, तब तक ध्यान नहीं देना है इन पे जब तक कि ऑक्सीडेशन नंबर कैलकुलेट नहीं करना है. बस ऑक्सीडेशन नंबर कैलकुलेट करते समय यू हैव टू take these into consideration. Naming में they won't be used. Okay, so moving on, how we'll name this? Always the first part will be named first. Like यहाँ पे भी, since the complex part was earlier than the counter anion, so हम लोग उसको पहले नेम किए. यहाँ पे चूँकि the counter cation is पहले, so पहले counter cation नेम होगा. So we'll first name the E. This whatever cation is over here, we'll name it as E. Then choose the ligand. अब कब complex part में आ जाओ, choose the ligand with the earlier alphabetical arrangement. Say it is L over here. Then X, as we already know, X, di, tri, whatever. Or if the di or tri is already present in the name of the ligand, then bis, tris, like that. X, the name of the ligand L. Then the next ligand in the next alphabetical arrangement, Y, L dash, its name. Then the central metal atom name. Okay, now here the central metal atom name will not be used directly. A modified name will be used over here. What is the modified name? Just add ATE to the end of the actual name of the metal M. Like say it is copper. If M is copper, then it will turn out to be cuprate. Okay, it is very easy to find out the modified name. Say it is zinc, then zincate. Okay, that is how it is named. And finally the oxidation number. That was simple. Nothing you have to do. You have to name this first, then the complex part, like we mentioned, like we named earlier also, then the modified name of the metal atom, and finally the oxidation number you have to find of this M. Now oxidation number we already know how to find. It's very easy for us, right? So this anionic complex can also be represented as an anion only. This complex, when represented just as an anion, is also an anionic complex. We saw that earlier. So इसको कैसे नेम करेंगे? The same manner, just we'll ignore that E part. Like यहाँ पे क्या कर रहे थे? When this part was removed, we just ignored it in this naming, right? In this special case. वैसे ही जैसे this one will be removed, we'll ignore that. Rest part we'll name as it is: X, L, Y, L dash, M, modified name. Okay, and then the oxidation number. Now let's move on with the examples. Some examples we'll do on this. So the first example is this. Now identify the type of complex first. As we can see that the complex part is present in the anion. Okay, the square bracket part is present in the anion, so this is an anionic complex. So since this is an anionic complex, so firstly this thing we'll neglect right now. This 3 or whatever it might be over here, this we don't have to take into consideration right now. Now what is K? K is potassium. So firstly potassium. Now what will be the next thing? After this you can refer to this. See, this E we named, then the next thing, the ligand we have to choose. So what is the ligand over here? Only one ligand is over here, so no worries about the alphabetical arrangement. Now what is the name of this ligand? You have to refer to the table for the details of this ligand. Like if you see, then this ligand is this one, C2O4 2-. This ligand is this one, right? This ligand is C2O4. This is C2O4 2-. What is its name? OX or oxalato. It is derived from the name oxalate, and the charge on it is -2. Okay, the charge on it is -2. Now what we'll do, we'll simply name the ligand like firstly the prefix tri, then the ligand name. What is the ligand name? Oxalato. Okay, trioxalato. Then the name of the central metal atom. What is the name of the central metal atom? We know chromium it is, right? Chromium, but the modified name will be used over here, so chromate, not chromium. In case of anionic complex it will be chromate. Now we have to find the oxidation number of this central metal atom. Let us assume this to be X. K का potassium का we know charge is 1. ठीक है, तो number of potassium 3, charge on it 1, chromium का number of atoms 1, charge on it chromium का number, charge on it or oxidation number of it X assumed. Then the number of C2O4 2- C2O4 ligands 3, charge on C2O4 wala ligand is -2. Add all these, equate them to 0. What we will find out? 3 plus x minus 6 is equal to 0. So x minus 3 is equal to 0, x is equal to 3. So x came out to be 3, so simply 3. What is x? The oxidation number. So that is how it is named. I hope you understand this example. You can revise it once after pausing the video. Now we'll move on to the second example of this anionic complex type. So on seeing this, we'll first identify the type of complex. This is an anionic complex. We can easily see because the complex is an anion. Okay, so now moving on with the next thing, we have to ignore the numerical prefixes over here which are already not there, but still, even if it was there, we have to ignore. So what is the step? First step, this Hg has to be named. So mercury, then inside we'll choose the ligand. There is no choice, there's only one ligand over here. So after going inside, we'll see the name of the ligand. What is SCN? SCN is a ligand? Yeah, it is. Now go to the table and see SCN is a ligand. At point number 8, its name is S-thiocyanato. Okay, or simply thiocyanato can also be named. Okay, so thiocyanato is the name of the ligand. So mercury, यहाँ चूँकि 4 it is there, and so it will be tetra thiocyanato. You understand why I wrote tetra? For 4. Tetra thiocyanato. Now what is this? Cobalt. Now cobaltate. I'm expecting that you can find out the name, that modified name. Now cobaltate we wrote. Now we have to find out the oxidation number of this cobalt. How we'll find out? We know Hg. How does Hg exist? So how does mercury exist? Mercury exists in 2 valency forms, right? +1 and +2. But the original one which we'll be using here will be +1, because it is not mentioned anywhere that it is mercurous or mercuric, so we'll be using mercurous only. Okay, like we use it generally. So we'll take the charge on Hg to be Hg +1. Okay, so this is +1. Now we'll find out the oxidation number. How? We'll assume this to be x. So number of Hg 1, charge on Hg +1, number of cobalt 1, assumed oxidation number x, charge on or number of SCN molecules 4, charge on SCN, you can refer to the table, it is -1. SCN minus, it exists as SCN minus, 4 into -1, Sum all this up and equate it to 0. You will find out this will turn out to be 1 plus x minus 4 is equal to 0. X minus 3 is equal to 0. X will come out to be 3. So the oxidation number of cobalt over here is 3. Simply 3 over here. I hope you understood till here. Now the third part is very easy. The third part is the neutral complex part. Now how we will name the neutral complex? Nothing has to be done. Nothing. Literally nothing. Now just this thing is given, no counter cation, no counter anion. Just name it how it is named. X सबसे पहले, then name of the ligand L, choose the ligands alphabetically, then Y, then L dash, then M, and then the oxidation number. In fact, it is simpler to name a neutral complex. Okay, so I hope you understand. So we'll move on with a few examples. You will understand. Like if we take the example of this one, you can see there's no counter cation or counter anion over here. So we can say that this is a neutral complex. So how do we name a neutral complex? We'll find out the ligand over here. So if we see the ligand, सबसे पहले this 4 is over here, so we'll write tetra. Or you could see the name of the ligand so that you could see whether it has a name di or tri. You can check पहले नाम देख लो, ताकि di or tri अगर होगा तो you have to use bis tris like these, no? So you will check where is CO. So CO, as far as I can see, it is over here. One sec, let me find out. Yeah, CO is over here. So what is the name of CO? Name as ligand carbonyl. Okay, so it does not include a base trace, so no worries. So tetra, then after that the name of the ligand carbonyl, tetra carbonyl. Then after that the name of the central metal atom. Okay, name of the central metal atom. Write the name of the central. What is the name of the central metal atom? Nickel. No modified name over here. Okay, no modified name over here, because this does not have a cation or an anion, anything. Nickel. Now we'll find out the oxidation number. How we'll find out the oxidation number? Let's assume this to be X, and CO, carbonyl, you can see it has a charge of 0. So how we'll see this? I mean, NiCO4, if we see the number of Ni 1, assumed oxidation number X, charge on cobalt is 0, and number of cobalt is 4. Sum this up and add it to 0, and X will find out, it will come out to be 0. So X is 0, oxidation number is 0, it does exist. We'll write over here 0. This is the name of this coordination compound. Now moving on to the next example. Now this example over here, this includes two neutral complexes together in a single compound, but when these two come together, the one which comes earlier acts as the cation, this part acts as the cation, and this part acts as the anionic complex. This part acts as the cationic complex, this part acts as the anionic complex, and always we have seen the one which comes first is named first. Okay, so we'll name this first. Since this part acts as a cationic complex, name this just like a cationic complex. So moving on, what is this ligand first over here? We are naming this as a cationic complex. Okay, so what is the name over here? This is basically this type, sorry, this type it is, where it is a cationic complex but it does not have a counter anion. यहाँ पे counter anion is not there, another complex is there. So वो अभी के लिए भूल जाओ. Okay, भूल जाओ अभी के लिए. अभी you just name this. Okay, like a simple complex. So name of this ligand first. So सबसे पहले di, then the name of this ligand we know, amine. Then since this is a cationic complex, the original name of the metal will be used, central metal. So what is the name of this? Silver, right? The name of the metal. Then we'll find out the oxidation number of this thing. Okay, so how we'll find out the oxidation number in this part? So that is not a big deal, how we'll find out the oxidation number of this silver. Okay, simple, just like we used to do it earlier. Assume this to be X. Since this silver we assume to be X, this will also be x. It is necessary. Keep this in mind. There's no reason for it. I have experienced this by solving questions कि अगर ये कुछ है तो इसका भी वही होगा. So we took this both to be x. Now charge on NH3 we know it is 0, and charge on Cn you can see from the table it is -1. Add all of them, multiply कर करके. So number of Ag 1 सबसे पहले, oxidation number assumed x, charge on a number of NH3 2, charge on it 0, number of Ag again 1, assumed oxidation number x, number of Cn 2, charge on it -1. Sum up all and equate it to 0. You'll find 2x is equal to 2 you will get from here, x you will get as 1. So the oxidation number of silver in both the cases is 1. So silver 1. Now the next, this part we have to name. Forget this part now. Forget this part. Now this part, when we'll name this part, we'll name as an anionic complex. How will it be named first? This di term will come over here, di. Then we'll see the name of this Cn in the table. The Cn is named as cyano. Okay, dicyano, you can see from the table. And this silver when it will come as an anion, no, in the anionic complex, it won't be named as silverate. This is an exception series. It won't be named as silverate. It will be named as, in its Greek form, argentate. Okay, you know argentum is the name of silver, so it will be named as argentate. It is also a modified name, but it is not as simple. That's why I included this example over here. This is the hardest of all. So argentate will come over here. You know it is the Greek name. Chunki silverate was not sounding good, so the scientists used argentate, the Greek word. So dicyanoargentate, and then simply the oxidation number, which we already found out, it was 1. So this is how it is named. I expect you to revise this example 2-3 times. Rest everything is perfectly fine. Next video will be coming soon.